Let us discuss the properties of the three types of radiations: alpha radiations, beta radiations, and gamma rays. Now, in my previous video, I had introduced these three types of radiations. So let us now proceed. Now, when talking about the properties, I'll be focusing on the three main ones. Number one, deflection by an electromagnetic field. Number two, penetration power. And last one, the ionizing effects of the radiations. So let us start with the first one. Now, when these radiations are allowed to pass through an electric field, they behave differently from each other. Alpha particles are positively charged particles, so they are going to be deflected towards the negative plate of the electric field. Beta particles, on the other hand, are negatively charged particles and as such are going to be attracted towards the positive plate. What about the gamma rays? Gamma rays are going to proceed in a straight line. Why? Because these particles have no charge whatsoever and as such are not going to be deflected to either plate. Now, one last thing. I want you to observe the degree of deflection of the alpha particles and beta particles. Compare these two. What you're going to note is that the beta particles are deflected more compared to the alpha particles. The reason for this is because these particles have a smaller mass and are therefore lighter compared to the alpha particles, which are heavier. And therefore, the beta particles have a greater degree of deflection. Moving on to the second property, penetration power. Now, when we talk about penetration power, this refers to the ability of the radiations, the alpha, beta, and gamma rays, to travel through a material before being stopped. So, different types of radiations have different penetration powers. Generally, the rule of thumb is this: the more energy that a particle has, the higher the penetration power. Now, out of the three types of radiations, it's the gamma rays that have the highest amount of energy and will therefore have the highest penetration power. These are rays that can pass through even solid objects. They can only be stopped by a block of lead metal that is more than 8 centimeters thick. Now, the reason why they have such a high penetration power is because they have no mass and they move at extremely high speeds. The second is the beta particles. So the beta particles have an average penetration power, not as much as the gamma rays, but better than the alpha particles. So beta particles can pass through a thin sheet of paper, but will be stopped by an aluminium foil. Alpha particles, these are the ones that have the lowest penetration power and will be stopped by a sheet of paper. And the reason for this is because they have a heavier mass and therefore slower speeds. Moving on to the last one, the ionizing effects of radiation. Now, when you talk about ionizing properties, this simply refers to the ability of the radiations, the alpha, beta, and gamma rays, to cause ionization in matter. So, ionization is the process by which an atom forms an ion, either by losing or gaining an electron. So essentially what happens is that when these radiations pass through matter, they interact with the atoms that are present. So they can provide energy that will remove an electron from the atom, causing it to become an ion. Now, not all radiations have enough energy to cause ionization, but all three in this case, alpha, beta, and gamma, do bring about ionization, but the degree of ionization is different. So what happens is that out of the three, it's the alpha particles that have the highest ionization power. Now, this is because of two reasons. Number one is that they are heavy and slow, and number two, because of the positive charge that they have. The alpha particles are heavy and slow, so this allows them to have more contact time with the particles, with the atoms, therefore bringing about ionization. Number two is that because of their positive charge, you find that the alpha particles attract electrons from the atoms they come across. So when an alpha particle comes across an atom, electrons from that atom are attracted towards the alpha particle. So they move out, they get knocked out of the atom, causing the atom to become an ion. Now, the second one, of course, is going to be the beta particles. So beta particles have a lower ionizing power because they are not as heavy as the alpha particles and they move at a faster speed. Gamma rays are the ones that have the lowest ionizing power. And the reason for this is because they have no charge, They are very light and have the highest speeds of all. So they have a very short contact time with the atoms. On a last note, I would like to point out something. Ionizing power and penetration power have an inverse relationship. So particles that have a high ionizing power will have a low penetration power. Let me give an example of the alpha particles. Alpha particles are heavy and tend to have low speeds. As a result, they have a low penetration power. But because of this, they get to have more contact with the atoms they come across, and therefore will have a higher ionizing power. This brings us to the end of part 2 of radioactivity. In our next part, we are going to tackle past cases equations on radioactivity. Be sure not to miss out.